Please welcome Dr. Alex Tournier.
Thank you, Birgitta. So thank you very much to the organizers for inviting me today. It's really a pleasure to be here. Yeah, so many of you. It's like, cool. When you're invited, you never know. And as Peter said, Sweden has been a country where we've heard that there's difficulties. So it's great to see so many of you. So the topic for today, I'm giving a talk today and tomorrow. So today I wanted to tell you about some of the physics I've been looking at in terms of explaining homeopathy, and to tell you about where what I think are the kind of the ingredients that we need to look at in terms of a physical theory. But before I go there, I just wanted to do a quick plug for the Homeopathy Research Institute. I'm aware most of you don't know who we are. So we are currently a UK-based charity dedicated to doing high-quality research into homeopathy. So the way we work is often to help researchers network to make sure that protocols are the highest quality possible, that people have all the support they need to make sure people publish in the highest journals possible, and so on and so on. So we make the link between donors and projects. Another aspect of what we do is to communicate about the research, to make sure that people understand the research in homeopathy. So that's a big aim of the charity, make sure that it's understandable, that people are aware, communicate with the public. And if you want to hear more about it, then talk to me. And actually, one of our trustees is here with us, Peter Vixven, over there. So you can catch him if you want to talk some more about the HRI. And please sign up to our newsletter. We send newsletters every 3 months right now, with kind of a digest, new scientist type articles about research topics. So now I'm going to have to plug myself, because in a few talks lately, people have just been questioning, well, you're a homeopath, what do you know about physics? So actually, I do know about physics. I did my bachelor's in London. I studied theoretical physics in Cambridge. I did my PhD in water structures in Heidelberg. Then became a homeopath as well, and I have been just about 10 years working as a consultant in maths and physics for Cancer Research UK in London. So I think I can talk about physics with some degree of confidence. I had really pointy questions once, so now I've put this slide. I'd like to really move on to homeopathy. And for this talk, I'd really like you to stop me and ask questions. Like, I know that the policy is wait until the end. For my talk, please, just go for it. Think it's a classroom, because if you're lost, it's not good for me. So I'd rather you ask your questions immediately, because then it will have a good discussion. So, really, two problems with homeopathy that we can see. The laws of similars and the laws of the minimum dose. The law of similars, basically, we know that if you have a complex system, such as the human body or any biological system, that's always going to be adapting to its environment, then you could have could induce a reaction in the system by some stimulation, such as homeopathy. So the principle of activation through a vaccine or through the anti-allergy injections, that kind of is established. That is, we know how to trigger a reaction in a complex system to get the system back to health. So this is not well researched yet, this whole area of similars. But conceptually, it's already kind of out there in conventional medicine, and conceptually we could see how we could go forward in establishing proof of this principle, how you get a complex system to go towards health. Now, the big problem we've had with homeopathy is really the minimum dose, the dilutions, the potentization. And here, we're really struggling because we always faced, well, it's impossible. You know, homeopathy is impossible because of the dilutions. So this is really what I want to talk to you about today. So, you know, to put it into perspective, in biology, you don't expect anything to happen beyond a dilution 10 to the minus 10. So that's, you know, 1 followed by 10 zeros. So it's a big, big number. But, and so that's at 5 CH, you're already at that level. So anything beyond 5 CH in standard biology, you would expect no effect. And we know that we can work very happily at 30 CH and have effects. So there's a big problem here. And I just want to tell you that 30 CH, just to put it in perspective and just to remind you, it's like taking a drop, putting it into the ocean, mixing the whole earth, taking another drop, putting it again in the ocean, mixing the whole thing again, and taking a drop. That's 30 CH dilution. So just to give you an idea of how big the dilution is. So we have a problem, really. Good. And then from the standard physics, so you know, we're always trying to go towards the idea, okay, then it's not some kind of remnant of the original substance. It has to be some kind of water structures. So I looked at this quite a lot because water structures was my PhD topic. So I can tell you that really in terms of the standard physics, we don't expect anything much to be stable in water beyond 10 to the minus 9 seconds. So, you know, you've got millisecond, microsecond, nanoseconds. It's really, really small. So we know that homeopathic potencies can be stable up to a year, and currently there's just no idea how that could happen. Okay. So staying positive, what do we want? We want some kind of mechanism that can have a memory. We want something that is going to work through potentization, that we know that the potentization, the actual succussion process, is essential. So we need something that's going to work with that. And we need something that's going to be bioactive, something that we give back to the patient and is going to trigger some kind of reaction. So I want to tell you about so what I consider that we know, that are the ingredients I'm looking into to construct a theory. And I'm going to tell you about the nanoparticles. So I don't know how many of you have heard about nanoparticles. Quite a few. So I think it's an interesting idea. I personally think there's some problems with it, which I'm going to show you. But that's for today. And for tomorrow, I will tell you about my own kind of favorite theory that kind of is able to explain most of the things I'm going to show you today. So let's jump in. So there's a few ingredients I want to tell you about. There's the fact that it seems that electromagnetic fields are involved. And also then the idea of a crosstalk of field effects. I will tell you all what these things are. This came up a lot in Barcelona, a few researchers confirming this effect. And then I'll tell you about some other parameters to do with ultra-high dilution. So to start with, I have to introduce you to Tournier. Tournier got the Nobel Prize in 2008 for HIV, and he has been secretly continuing the work of Dr. Benveniste. And basically, he published papers in 2009, just after his Nobel Prize, looking at dilutions. And I'll show you some of that. And he presented it at the Lindo presentation, which is the conference for Nobel Prizes. That is only if you have a Nobel Prize can you go to that conference. It's pretty intense. There was rumor that he was going to move to Shanghai, but that's kind of died now. So what did he do? Well, it all started with an experiment he did where he was looking at parasites of lymphocytes, and it's a bacteria called Mycoplasma pyrum, and he was studying the relationship between the lymphocytes and these parasites. So he filtered them out using smaller and smaller filters, and played around with trying to see how. Well, basically what he did is he filtered all the parasites out, and then put back the solution with lymphocytes that had no bacteria, and within 2 weeks, somehow the bacteria reappeared. So that's very weird. So he was starting to think, okay, so something in the filtrated substance, in the filtrated water, has been able to inform the lymphocytes such that the bacteria has reemerged. So he started to think, okay, so there's something here about information. So what he did then is he went back to the experiments by his friend Jacques Benveniste. So I don't know how many of you know about Benveniste? Yes. So he's very famous for publishing the kind of Nature paper in '88 about the memory of water. And he did, he started the whole thorough investigation of homeopathy using a phenomenon called degranulations, which is some allergic type reaction. So he started this whole field, and he was director of the French CNRS before publishing in '88. At which point he basically lost everything. And when I met him, he was working from a construction site shed in the parking lot of his old institute. So they had a big institute, and he was allowed to work in a cabin in the parking lot. So what he did, and he put together an instrument, which is this one, which he used. If you put a vial here into this apparatus, which is basically a coil, then you can measure the electromagnetic properties of your sample. So what you do is put this into the coil here, and you have some kind of amplifier, and then you can record it on a computer. And then the computer can analyze the frequencies present in the signal coming out of the sample. So Montagnier, with his bacteria, thought, okay, there must be something in the water that I'm diluting, in the water that I'm using with my bacteria, that must have some information. So let's look at it using this apparatus. So he starts with the bacteria, filters it out, and then succusses it. So he uses something called vortexing, which is basically the modern lab equivalent of a succussion. So instead of shaking like this, it's kind of a machine that whizzes very quickly and shakes it like this. So he uses that instead of succussion. And then he does a series of dilutions and then succussion, but he uses actually vortexing up to a D12, so 12x. And then puts it in the machine, and lo and behold, he can see a signal in the frequency domain. So these are the frequencies, and here you can see a difference between the controls. So these are succussed controls and the actual the bacteria that's gone through this whole process. So there's something about electromagnetic information that's being captured through this process. Although the bacteria has been filtered out, has been diluted and succussed, then some information is there. Now, he was able to show that the succussion process or the vortexing was essential for this process. So if there was no vortexing, there was no signal. And also, he only gets the signal if he dilutes the sample. He says that if the sample isn't diluted, then there's just too much interference. I don't know, but that's what he says. But basically, yes? So vortexing is another, it's, I don't know if you've ever, yeah.
Yes, I just asked what vortexing meant.
So vortexing is another way of doing succussion. So the standard succussion process is up and down, but vortexing kind of goes like that. And it's in all the biology labs, you have a machine that does that. It's just when they want to mix something quickly, and it's quite violent as well. So it's quite a violent shaking that's similar to succussion. Yes?
But it's done only once?
It's done at every step. Yep. And Montagnier showed that if you didn't do that, it didn't work. Well, actually, yeah. And so then Montagnier went beyond that, and he was able to show, by breaking down this part of the experiment into all the bits of the bacteria, he was able to show that it was the DNA that was actually responsible for the signal, and then he was able to show that it was a particular part of the DNA, the part of the DNA that's responsible for a protein that's responsible for the bacteria being able to connect to the lymphocyte. So it has kind of a membrane binding protein. I think it's called cohesin, that enables it to bind to the lymphocytes and actually confer to it its pathogenicity. So it makes it able to cause harm. So that stretch of DNA that codes for this particular protein is what gave rise to this particular signal, right? So that he was able to show that. Anyway, so moving on. Yeah, and he was able to show that it didn't seem to matter much how many cells you had at the beginning. As long as you succussed it, you got the signal. And it's also, as I said, he only found it in high dilutions, or relatively high dilutions. So 7x, 12x, something like that. To put this in context, he was not really the first to discover the electromagnetic signal in biology. It was studied a long time ago by Alexander Gurdjieff, with the biophotons, and you looked at them in the UV spectra. So just to remind you, when I say electromagnetic signal in physics, electromagnetic signal also is photons. So light is an electromagnetic signal in physics. Does that make sense? Yep. And then it was also investigated by Fritz Albert Popp, and he found also that the source of the signal was DNA. So, it's not the first time that this type of result has been reported. Now, it seems so, taking a step back from these experiments from both Montagnier and Benveniste, it looks like we're able to detect the electromagnetic signal through the apparatus I told you about. This can then be recorded, And actually right now, Tournier is working on machines that would analyze the signal to be able to use it as a diagnostic tool for infections, for example. So if you have a blood sample, you could analyze the signal and see if there's infections. And then what Benveniste did, he actually had a recorded signal from a sample and then would play it back to a blank sample and was able to see that this informed sample had biological effects. So to me, it's just indications that this whole electromagnetic, so there seems to be something to do with electromagnetism in the process that we're looking at. Yeah, so that's what I said. Now, so if the first ingredient was electromagnetic radiation. Now, there's another thing that came up, which is the so-called crosstalk effect. And this is slightly different, although related. Here, and to illustrate what I'm talking about, here it is. So, what Montagnier did, if you took DNA, so the DNA I was telling you about earlier, and you succussed it and diluted it up to D6, and you put beside it a water sample that's just blank, and you leave the two overnight, then 18 hours, and then the DNA sample shows the frequencies I was telling you about. It has a signal that you can measure with this apparatus. And then, but lo and behold, the water sample also has the same signature now. It has somehow caught on the information. Does that make sense? So these are sealed vials, so the information somehow has passed from one to the other. Now, other researchers, so this is now on frogs, the experiments done by Christian Endler in Austria. He's been looking at frogs, especially tadpoles, and how thyroxine 30X can influence the development of the tadpole, and you can do that very reliably now. And basically, what he does is he counts the numbers of tadpoles that have gone to the four-legged stage, and you can do that. So experiments look like this, and you just look over time how many tadpoles have reached a certain stage of development. But usually he would just put the thyroxine 1X into the bath with the tadpoles, and that would work. But here in this experiment, what he did is he put a sealed vial of thyroxine. So he didn't put the actual homeopathy in the water, he put a sealed vial into the water, and that was enough to create the effect. So there's a substantial difference between the two groups. Yes? Days, I suspect, here.
Jag frågade just om tiden, om det var timmar, dagar, veckor eller månader bara.
Is it hours?
Yeah.
Are you talking about hours or days?
It's days. I suspect it's days. I'm sorry, yeah. I will check it, but I think it's days. Yeah.
Have they repeated that experiment with a Faraday cage around the tube? In other words, to actually block out the field?
No.
No. Okay.
But the idea of the Faraday cage is a good one, yeah. I'll mention something about this a bit later. So that's with frogs. Basically, you don't need to actually put the homeopathy itself, just the proximity seems to be enough. So another researcher, Stefan Baumgartner in Switzerland now, has been using plants. And he also reported this in the conference in Barcelona, is they've reported a very strange effect, which is that when they use, they have plants that actually don't look like this. They put in little packets, flat packets, and then they stack them 10 by 10. So, and they're like on a coat hanger. So there's got 10 of the placebo, 10 of a certain remedy, 10 of placebo, and so on. And it's all computer coded, so they know exactly. And then they looked at it in detail and realized that the placebo group, the plants that were in the middle of the placebo group were not affected, but the plants that were closer to the verum group, the ones receiving the remedy, were affected, as if they were receiving the verum. And the effect is linear. That is, the closer the plant is to the verum group, that is the group receiving the homeopathic remedy, the more it looked like it had received the homeopathic remedy. And the effect is linear with distance.
Not inverse square.
I can go, why it's not inverse square? Because there's a reason why it's not inverse square. Yes?
What can happen if I have a gospel or the arnica and a lot of cesium together?
Very sharp question, but you're springing way ahead of my talk. So we'll discuss this. But good. That's exactly where it's going. So there's a linear effect. So again, this is there's no reason to believe there's any pollution or any. It seems to be really some kind of field, and it's here the distances are centimeters, and that's kind of what we're looking at. All the experiment work on centimeters, tens of centimeters max distance range. So before I go there, so I just want to tell you. So we also had in Barcelona Gustavo Bracco from Cuba who mentioned this effect, and he's noticed it when they, for example, they prepared a placebo at the same time as a verum, so they use succussed placebos. And if they prepared a succussed placebo at the same time as a succussed verum, the placebo would not be a placebo. So they have these machines that can do two things at a time. And they noticed that they had to make them really separately, because if they did it at the same time, the placebo would not be a real one. So this is not published, but he told us in Barcelona. So this is at least like 4 big groups in the world that are reporting this weird effect. So again, what we have is, we know that if you heat it or boil it, it doesn't work anymore. If you freeze it, if you freeze the water, it doesn't work. And many studies have shown, well, a few studies have shown that if you don't have succussion or this vortexing, then it doesn't work. So what do we have? We have dilutions, we have succussion, we have something that's bioactive at the end, we have this effect of crosstalk I told you about. We have something to do with electromagnetic information in some sense, and we know that it's heat sensitive. Whatever's is created is going to be quite sensitive to heat. So where do we go from here? Nanoparticles, that's been hearing about, or like quantum coherent domains. That's for tomorrow. Today, I'm going to tell you about nanoparticles. No way.
Yeah, sorry to interrupt, but I just wonder, you started off with saying that the memory in the water would only be there for less than a second.
Yeah.
And to continue this, it just seems I need to understand that.
Yeah, so I'm just, so I'm going to talk a bit faster because I'm being told. Very good. I was just telling you that's the scale of the problem. We have a huge problem. So now I'm going to now I've told you what we know. I'm going to try and resolve that by telling you about the type of theories that are out there to explain it. So nanoparticles, an Indian group by Chickamani discovered that there was gold nanoparticles in 30C and 200C. So they were able to detect those. So nanoparticles, any particle that's about 100 nanometers, that's about the size of a protein. A big protein. So protein is more down here somewhere. But it's the size of a virus, say. And actually, they used this type of nanoparticles to treat cancer by binding proteins on the sides of these nanoparticles. So I want to show you quickly that one of the ideas they had is that the dilution process would actually take the top layer of the remedy. And so what they did here is that they show that the number of nanoparticles they're measuring doesn't change much up to 11C if they take the top layer of each dilution. So it seems, we know nanoparticles can be effective in biological terms, and we know through these experiments that in principle you could have kind of constant concentration of the nanoparticles if you do it in this very specific way, up to kind of 11C. Now, so, it's kind of interesting. We know it's bioactive. You need succussions to create nanoparticles, to extract nanoparticles from the glassware. And we know that we can keep the concentrations of nanoparticles. So now, time is running out so fast. Problems are, of course, that you need to dilute from the top layer, which is a big problem because we know in practice, homeopathic pharmacists tell us it's not the way it is. And also, if you look at this concentration, that's about 100 nanogram per milliliter. And to put the context to this, if you look at the biology papers, nanoparticles are bioactive at about 100 micrograms, that's 10 to the minus 4 grams. But aurum nanoparticles have been measured experimentally at 10 to the minus 10 micrograms. And basically, for this remedy, if you took aurum to get to that level of concentration, you would need to drink 4,000 Olympic swimming pools. To put it another way, if you were to put one drop of a cough syrup into 40 swimming pools and take from that a spoonful, that's basically what you're doing here. Okay, you're diluting into a standard homeopathic like aspirin. You're putting it into 40 swimming pools, and you're taking a bit of that, and that's supposed to be biologically active. So, in my opinion, we still have a big scale problem. That is, the dilution problem is not gone away here. It's still very much present. So, I like the idea of the nanoparticles because it's bioactive and so on, but it still needs a lot of work. Now, okay, no, we need that. So, yeah, the crosstalk, it doesn't explain crosstalk because it's not electromagnetic. Electromagnetic it doesn't do, and it's not going to be very heat sensitive. So I see problems with nanoparticles, and it needs some more work for me to be convinced. And basically, this is the point where I'm going to leave you today, because tomorrow I'll tell you about the quantum coherence domains, which I hope explains a lot of, or is able to explain a lot of the things I showed you today. So thank you for your attention.
3 minuter. We have time for a couple of questions, so please. Please come forward. You had a question there. Did you get it answered? Please stand up.
The what?
Okay.
That was the language paper. Oh, sorry, could you...
Any questions? Yes.
You want me to go over it again?
What does the word verum mean?
Verum is in like all the trials. It means truth. It means the actual substance we are trialing. So it's kind of the inverse of placebo. So when you don't, you see verum, placebo. Verum is whatever we're testing. The substance. Yeah. And sometimes the substance doesn't quite capture it, so we use verum. Yeah.
Okay, it's not actually a question, but what you are telling us about how small amounts of substances can affect animals, like these small ones. That means I would suppose that's why even very small amounts of environmental poisons can affect living creatures so heavy, even, or what do you think about that? Even if it's not very much, because it's...
I mean, it's a completely different field for me. I mean, like bees, we know they're being influenced a lot. I mean, levels of hormones really, you don't need, they work at very, very low concentrations. What I'm interested in really in this talk is when you don't have anything there. When you're beyond a 12C and nothing happens. Because I'm interested in how homeopathic remedies work when there's nothing there that could do it. So not a single molecule. Whereas, yeah.
Yeah, my name is Chris Jorgenfeldt, and I always feel very comforting by the fact that science today can only explain the 5% of the universe that consists of matter, and they have no idea what the other 95% are. Doesn't that comfort you?
Interesting question. I don't think it comforts. It's not a comfort. It's just a fact. And I think it's fascinating. That is, as a scientist, we need to be reminded all the time that we don't understand most of the stuff. And that's why we're doing, the process of trying to understand things. And as soon as we start to think, oh, I know the truth, that's when things go downhill. If you assume you know, then you can't discover anything.
Thank you very much. Thank you very much.